Welcome to the Data Coffee Break podcast. I'm Marc.
And I'm Christian.
If you are passionate about data like us, take a seat, relax, and join us to our coffee break where we discuss all things data.
And remember, there are no filters, no PR.
It's just a real life experience. So let's begin.
So are you going to Portugal then?
I am. Thursday. I'm going for a good, nice trip. 20 degrees down there.
Nice.
And doing my half marathon.
Half marathon.
So
already, wow.
We all stressed about it at the moment. It's going to be a good fun, a good little break for everyone. Anything new on your side?
Not much. I'm being busy with the podcast, with work, and trying to lose weight. I'm getting there. Yes.
And sports.
Yes, exactly. And sport.
Important is to stay on track.
Exactly. So what are we going to discuss today?
Yeah, today we thought, obviously, that we did a great episode with Dennis last week. But a lot of people might actually wonder first, like, what is data engineering? Because we kind of dive a lot into some very specific points of data engineers' challenges. And we discuss a lot about, for example, security, but some aspects of toolings and things like that. So we thought, let's do a lightweight episode for everyone. We can actually more give an introduction of data engineering so people can understand where it stands in the space and the value of this field.
And also for everyone out there that is looking at making a change to understand better what to expect from the role, I think this is quite important. And I think this episode should have been released before.
Yeah. I think we were too excited to speak with Dennis. That might be why.
Exactly. Reasons.
Better later than never.
Exactly. So shall we start by defining what is data engineering?
Yeah. I mean, my point of view, I would say it's a role or field where individuals help to basically gather the right data, structure the right data, treat this information and prepare it for any business logic, maybe or any other tools that might require.
I agree. You touched on something really important there, which is collecting, managing, and converting data. So the data engineer is the one that gets all these, let's say, raw data or data at its more primitive format and converts it into something useful, like converts it into information that someone later down the pipeline, such as a data scientist or a business analyst or data analyst, can actually use and interpret on top of it.
Exactly, yeah.
Data engineering actually is at the beginning of the process. We live on a period of time where AI is taking a lot of, let's say, of the reflectors, a lot of the attention, but definitely the role of the data engineer becomes really, really important there because, as Dennis just mentioned, bad data in, poor model out.
Yeah. Obviously, you remember a couple of years ago, The Economist, like big title, data is a new gold.
Yeah.
And I remember reading a couple of years ago about that, and it was all about people who will work in data will have like the sexiest job. And a lot of people study like math and statistics and went to do some data scientist role, etc. And what I learned quickly in my first few years when I started to work in London was a lot of those individuals who started to work as data scientists or all those roles where they were supposed to crunch the number and deliver value for the organization. Yeah. Most of them were spending a massive amount of their time actually collecting the data or cleaning the data. And that's where in the last few years, I personally seen, maybe you see it in a different way, the rise of the data engineer role. Because data is so important now, we have to invest on it, but organization didn't really understood what was important first to do. That's the way I perceived it in the past few years.
One of the things that I would say as well there is that things became way more sophisticated very rapidly. When the data became big with frameworks such as Spark, then NoSQL databases. And at that point is when I started seeing, like the rise of the data engineering, because colloquially you can say that everyone can run SQL, can write SQL, but not everyone knows how to actually properly build Spark or, Python or Data Pandas data engineering pipeline, right?
For everyone to see this space, like if we, let's say, split it in three big buckets, there is a part of first data ingestion and the storage layer.
Yes.
Second part is like more transformation and data processing. And after is managing this data overall and I would say governance. Data ingestion and storage. What do you see important for everyone to be informed about here? I see like first ingestion. Is it batch? Is it real time?
Yeah. Definitely understanding the way that you will tackle that ingestion. If it's real time, we're talking about event-driven data. Kafka, for example, this is the first thing that comes to mind. But event-driven data, that's when we talk about real time. And batch is, I would say, then you treat that as your, I want to air quote, typical hourly, overnight type of processing. So, and the way that you handle that is the important thing to define there. What is the velocity of my data, right? So I think if we take the 3 V's of big data, velocity, volume, and variety, right? So at this point, between batch and streaming, we're talking about identify the velocity of your data.
Because sometimes it's business critical to have near real time or instant data. We spoke, for example, with Dennis Lee, very well-known use case of fraud analysis. This is like real time data that needs to be ingested and analyzed to be able to say, yes, we accept this transaction or not. At the opposite, we all have the case when you order through, let's say, a website, and it's only a couple of hours after you receive the actual email saying that your order has been accepted in process. And that's actually an example of seeing the data pipeline is being, in this case, more batched and delayed in some aspects.
Exactly. And I think that takes us to the second piece, which is your storage. Because one thing is that how fast you are processing, but the second thing is that how fast you are writing into your source, right? And whether that, depending on the type of data, the variety and the volume, you might select or choose a different technology to do so. An example of this is a typical, going back to those events, if the events comes in JSON, you may think about that. If this is from an application, I might put it into a NoSQL database that can be more into the index kind of approach. Or if you're building a lake.
Can you explain maybe for some part of the audience what is NoSQL? It can be seen as like a very unusual term.
Yes, these databases are actually, contrary to what other people might think, they're quite old school. But the name of NoSQL was actually adopted, I would say 10, 15 years ago. But the whole point of this is that the storage and the retrieval of the data is not in a tabular way. It's not a table, right? So the concept of having, for example, if you think about Excel, you have your cells and your columns. A NoSQL database have a different format into this. And what that actually gives you is that a freedom of your schema, because your schema might be changing, right? It's called the schemaless. Yeah. So you don't need to have something as strict as I'm expecting these columns as part of my table as you do with SQL. So the NoSQL are very used into these event applications that needs to do writes and
event-driven.
Yes, event-driven and read and writes that are going quite fast. So that is actually one angle of this. And the other angle of NoSQL databases is that usually use them also to index your data, right? So for search, quick search of a specific value, that's when you use a NoSQL, which is contrary to, for example, building a lake where you put all of your data in a storage bucket. And that is for further processing. That is like a raw data that a data engineer will take and make it more useful for a data analyst or a data scientist. Whereas the NoSQL, in my experience, you usually keep them there. And then to transform that data, you go through a very different process. Most likely, you will just read and retrieve from it.
And what's incredible, actually, is the variety of databases available for NoSQL structures, like well-known names such as MongoDB, DynamoDB, Couchbase, if I'm correct as well.
Elasticsearch.
It's quite incredible, the variety we might have. They all have like some different variants, I would say. But a wide range of choice is available for those data engineers and for to develop those business applications as well. So coming back, we dived a lot in NoSQL. But come back to the point. I think you were making a good point.
Yeah, I was just saying, like, depending on your requirements of what you're going to do with this data and how fast you need to write your data, that is also part of your choice of storage layer, right? Again, my experience is that if you're building that data lake, that is when you put it into a storage bucket, or when you are going to index your data, when you're going to store your data to be retrieved near real time by an application. And that's when you use that NoSQL database.
I guess like when we say transformation and we link that to data ingestion, the first thing will pop to my mind, and that maybe we should have said that slightly earlier. There's those three important letters that we see in the industry, which is E, T, and L. First one is extract, second is transform, and third is load. In a way, like we kind of covered the data ingestion from the business application or whatever system. This is the extract. Now, when we're looking at data processing and transform, this is a transformation. And one important thing that we see this transformation step, we were speaking obviously about this raw data, where obviously the cost of storing is very low. So it's better to at least have the data somewhere. A big part of a data engineer is like to prepare potentially this data in different stages, let's say.
Yes.
We have the raw phase, and we have a next phase where is cleaned, maybe structured in this case. And we have like a later stage where it's basically prepare more with business logic and joined with all the data. And that's something we see obviously very regularly. Those three different type of stages you will see in your data preparation pipeline that will load the data into another system. Agree on that?
You don't necessarily need to load into another system, but in terms of transform, my experience is that data engineers will prefer big data frameworks such as Spark in order to do their transformation. And transformation can be something as simple as enriching the data, bringing new data, combining two data sets, or adding more columns into a specific data set. Something more complicated, such as validating data quality based on conditions, regex, or even cleansing the data. And this is important because in the context of big data, every single column matters. Most of these cloud data warehouses or big data containers are columnar data stores. And a columnar data stores, by definition, means that if you bring unnecessary columns, you can really explode the amount of data that you have, right?
Absolutely. Yeah.
Another angle of this is that more like a SQL-based transformations using dbt or data form. I want to be very direct here by saying that if you want to be on data engineering, there is an expectation that you know Python, that you know the basic of Spark. And if you talk about dbt data form, that goes more into the analytics engineer, which I guess that would be an interesting episode to have. But definitely, if you want to call yourself a data engineer, you need to know your data frames inside and out. That's something that I would say.
Yeah, we discussed that the rise of dbt. One of the big factors that helps dbt to rise is the aspect of applying CI/CD principles, more like software engineering principle, when you can come back in time more easily. And on the other side, Spark has a big data processing framework. And we have so many data engineers and analysts overall will learn Python, which is becoming such a standard. So you will have PySpark as your entry point to basically using Spark. So that means you can do any kind of data preparation, any kind of enrichment that you used to do with Python, and providing on the top of all the libraries. The advantage of Spark or the like of all the open source product like that is like taking advantage of scaling that across clusters and processing this data very fast. One of the popular language when it comes to data engineering that apparently seems to be less and less prominent is Scala. It has the advantage of being like derivative initially based on Java, and has like the advantage of being able to scale very easily. It seems to be more for the old school programmers in the space.
Yeah, the ones that started with Hadoop, and MapReduce.
Exactly. Yeah.
But I would also recommend Java. Java is not going away. I see it a lot with Apache Beam, Beam starts from batch and stream, and it's used a lot for streaming systems. It's not as popular as Spark, but definitely, it's widely used. And Java is the primary language there. Quick one. If you're enjoying this episode and our show, please make sure you follow us on LinkedIn, Instagram, Twitter, and TikTok. Links on the description as per usual.
Also, if you'd like to grow this community with us, think about sharing this episode with a friend or a colleague interested about all things data.
Now, back to the episode. Having a data lake is one thing, but having a governed data lake or a governed system is a different one. And developing with security first in mind, that goes into so many directions here, right? In our episode last week, we touched a lot into packages, Python libraries, but also data engineering is heavily on creating the permissions or creating the data in such a way that can be governed and discovered by others. So what do you think there?
Yeah, I guess it's not the kind of realm of activity we initially expect from data engineer. I guess maybe business leaders who recruit data engineers or who put in place like a data team don't think about that as first of mind. It should be like one of the first value for data team in an organization. But having made secured, making sure even the raw data is allowed to access and actually what's inside this raw data. Because it's raw, we don't usually think about the risk involved in this case. We always have very tight control into our relational databases because it's usually quite easy to apply some row level security or even column level security, but we don't really think much about those raw data and those intermediary stages. Who has access to it? Or can it potentially actually be accessed outside the organization? Sometimes it does happen, unfortunately.
And I think it's a bit unfair to say that this is on the data engineer to define, right? So 100% agree.
It's a cross-team work.
Yes, exactly. But I do believe that data engineering is getting more and more into this space of governance, security, because as we mentioned at the beginning of the episode, the data engineers at the beginning of the pipeline, right? So, and you touched on something really important there, which is the raw data that sometimes is overseen because it's usually not analyzed. There is this statistics of, I think, only 13% of data is analyzed or much less than that.
Which is mind-boggling when you think about the potential value. Yeah. What do you think about the part where those data engineers can be creative, ways that the business was not expecting and that could bring value?
It's an interesting question. I do agree with you that a lot of data practitioners, including ourselves, are like business requirement driven. My experience, and actually this was with Dennis as well, or with other data engineers, is that they find ways to make them more cost effective. Those data pipeline steps to make them really efficient. I think the multi-language pipelines that we touched on last week is something like really creative to say, actually, this step is going to be much efficient. I will use less CPU. I will use less resources from the cloud. And my data pipelines are becoming faster and more efficient. That is something that I see a lot of creativity going there. The other thing about this is the scalability. I see a lot of the time that data engineers have or build these pipelines to don't change it, to support that. What happens if my data pipeline fails?
Resilient.
Yes, more resilient. That is something that I always see data engineers and being so proud when they create it. And I always very admire, right? So I create this pipeline that is not going to change in the next amount of years, right? Or very little maintenance.
Very long-term vision. It's great.
Yeah. So it's like this. And there's always one word that I love to hear from them, which is this pipeline is elegant. It's an elegant solution.
I like the angle you take it. And maybe answering myself to my question, I realize how important they are to have them at the table because they know which data sets are available to the organization. They know which raw data is available. So when they are in those kind of business meeting where the organization is trying to find new ways to help customers, new ways to find new revenue stream, new way to be more efficient, they come with original angles because they have access to such a breadth of data.
Honestly, if anyone listening would like to explore a role, this is something that is hot in the market. The skills are highly regarded and definitely something really advisable if you are interested in to get into it.
And it's a great starting point in terms of career because you're really exposed to the initial pain points of an organization. And if you looking towards raising internally to more like data analytics engineer or like a data scientist, having this kind of background of data engineer is great because you basically know the first step before getting the right data in the right hands.
Absolutely. Mark, that was fantastic.
Yeah. And I think with that, I'm going to let you go to the pub. I think you have a night out. Have a beer for me and for the community.
Yes, I will do. Thanks for listening to this episode. This podcast represents our views and not the ones of our employers.
Our mission at the Data Coffee Break podcast is to inform you and help you grow in this always changing data field.
Follow us and get into the conversation with the community on our LinkedIn page and Instagram.
See you next Tuesday. And until then, keep your data caffeinated.